All right, so the skeletal system. Why do we have a skeleton? What do you guys think? Why do we have this skeleton? Jason says to move. Good thinking. What else? Ramiro agrees to help us move. Good thinking. Jason has not be a slug monster. Yes, I imagine we would look much more like a slug monster without our skeleton. So to provide some type of support for all of our flesh, right? What else? Will says to protect our organs. Good. Yeah. Think about your rib cage, ladies and gentlemen. Think about all the important organs in that space of our body. Think about your spinal cord, that super important organ that runs down your spinal cord, and then inside your skull, the brain. Kimberly says, help us give structure so we're not a blob. Good. Yeah. Gives us some type of structure. If you look at the image up on the screen here, you can see we're able to sit up straight. We're able to stand. We're able to walk. We're able to hold the muscles, right? Because of our skeleton. Just like Montezuma said. Amani says for protection. Think of the skull, right? Just like Amani said, it protects, right? Protects organs. Doesn't our skeleton also help us eat? Without our jaw, our mandible, we call it, closing up top to our maxillary bone, we wouldn't be able to break down food into small pieces that we then could swallow and then slowly digest. It would take longer for our bodies to break down that food if we just ate stuff whole. One of the important reasons why you should chew your food well. You're actually helping your body digest food when you chew your food well. And in fact, there's some other things happening too, which we'll talk about in your mouth that helps you digest your food well before you swallow. But your skeleton is definitely helpful in that regard. It holds our body in a particular location. Yeah, right, Amani. It gives shape to our body, right? Kimberly says we wouldn't be able to walk. We wouldn't be able to pick up stuff, right, without our skeleton. The bones in our fingers, the bones in our hand, the bones in our arm all add to a motion that allows us to pick things up, right? So the skeleton has a lot of important purposes to it. And in fact, the bell work talked about some of those very important functions. So hopefully that gave you a little bit of a primer into how to answer that question. So when we're talking about the skeleton, our bones, we classify those individual pieces based on their shape. And so we say, there's nothing to write yet. We say, depending on their shape, we'll give them a particular category or name. And then each of the bones will fit into those 4 categories. So we have bones that are long, like our humerus in our arm, like our ulna, like our radius. We call those long bones. Just like the bones down here in our leg. We call these long bones, long bones, long bones. We also have bones that are flat, like the bones on our skull, the bones in our face, the bones, where's the other some flat ones? Hip bones. So we call them flat bones. Hey, look at that. And we actually call it, this is probably one of the only times when we actually call things how they look. Then we have some bones that are irregular shaped. They don't really have a clear shape to them, like the bones of our spinal column, our spine, these little vertebrae. We call them irregular bones. And then we have really small bones, short bones, that make up our hands, our fingers, and some of the bones of our rib cage. We call those short bones. So we got long bones, we got flat bones, we got irregular bones, and we have short bones. And then in those categories, we have lots of different bones throughout our body, about 206 bones to be exact. When you're younger, you have a lot more. But the first type of, we'll talk about that later. The first type of bone we're going to focus on is the long bone. So the bones of your arms, the bones of your legs, these long bones. And the long bone, if we were to cut it open, has a different look in different locations. In each of those locations, we have a certain name to them. So we'll talk a lot about bone marrow, Jason. Bone marrow is something we find inside the bones. It's very important to us. So the ends of the bones are known as the epiphyses. The ends of the bone are known, I hate that thing. If I stop, it'll go away. Are known as the epiphyses. The center of the bone is known as the diaphysis. So these are the epiphysis, the diaphysis. Now, the epiphysis that happens to be closest to the area of attachment is called the proximal epiphysis. Remember that word proximal and that word distal? The proximal epiphysis, if we're talking about the humerus bone, this bone right here, this would be the proximal epiphysis because it's closest to the attachment point here in the shoulder. This end of it would be the distal epiphysis. And they look different. They have different bones attached to them. The center is always called the diaphysis. Now, in both ends, both epiphyses, we have different inside material than what we find in the center of a long bone, the diaphysis of a long bone. In the diaphysis, we find compact bone. It's really hard, really dense bone. If you magnify the center of the diaphysis, you'll see this compact bone. Even though it has these openings, these canals, it's pretty dense. It's pretty dense. In the very center of the diaphysis is where we find a very particular type of bone marrow. We call it yellow bone marrow. And that's different than what we find in the epiphyses, which is a different type of bone that has a spongy-like appearance to it. It has all these openings. Inside these openings, we find red bone marrow. Now, red bone marrow and yellow bone marrow do very different things, and we'll talk about those in a moment. We'll talk actually about all of these different parts in a moment. So let's take some notes. General features of long bones. Please write that down right underneath that line you drew, underneath the title. So the first thing I want you to be aware of is the shaft of a long bone. This part is known as the diaphysis. When you're saying that word, diaphysis, diaphysis. And that's the shaft of the long bone. The end of a long bone is known as the epiphysis. So when you're saying that word, epiphysis. So we have two epiphyses, one epiphysis here, the distal, one epiphysis here, the proximal. And those are the ends of the bone, while the diaphysis is the center of the bone. Now, on the end of each epiphysis is some cartilage. Now, if you've ever eaten a chicken wing before, you've come across articular cartilage. You just probably weren't aware of what you were chewing on. If you're those type that likes to chew on the ends of the bone after you clean off that chicken wing, the chicken wing is basically, if you were to think of a chicken in terms of the human, the long bone, the humerus, is the bone that looks most like what we're looking at up here, and then this part and the fingers on a chicken look a little bit different because they've adapted slightly different. But you'd have a shorter bone here, two of them. You have a radius and an ulna, which we don't see here, but they are different types of long bones. And then you'd have all these short bones. for the wings. But nonetheless, if you were to break the bones apart, you were to look at the very end of that bone, it would be smooth. It would almost have a little shiny appearance to it. You're looking at articular cartilage. Yeah, so it looks like it's what, 12:04. So guys, you're going to want to make sure you watch the videos I post if you are a senior. If you are a senior, you are supposed to go to a meeting. Do you guys need the meeting link? Seniors? Okay. Oh, shoot. I meant to send that to everybody, not just Jason. Okay, let me send this to everybody. All right, guys. Sorry you're a little bit late. Head over there if you're a senior. Otherwise, if you are a junior, please remain here so we can keep talking about bones. All right, so the articular cartilage is there to help reduce friction between bones, because this part of the bone would be in the shoulder, or this part of the bone would be attached down here, depending on where this bone is found. And it's basically dense connective tissue that covers the end here, and it helps reduce friction. It's nice and smooth. It's made of hyaline cartilage, if you remember from our histology section. Now, spongy bone. This is the type of bone you find in the epiphyses. Spongy bone kind of looks like a sponge. That's why we call it spongy bone. And if you notice, it has a lot more open space than the compact bone does. Now, having spongy bone is an advantage to us. If our bones were all compact bone, they would probably be really heavy. And so by having these big ends made of spongy material, still hard, still strong. In fact, because it's spongy like this, it's really strong. It reduces some of the weight that we need to carry around when we move. If we had all compact bone, our bones would be a lot heavier than they are. And it would require more energy to be able to carry them around, to move them around. It also gives us a spot for red marrow. Now, red marrow is very important because it produces the blood products that we need. Basically produces our blood. Produces the red blood cells, and this is where we produce white blood cells. And I'll show you an image in just a moment of what the red marrow looks like in the spongy bone and what spongy bone looks like. But now, sometimes they're found in the epiphysis, different areas. There's these epiphyseal plates, we call them, or epiphyseal lines. And you can see the epiphyseal line here, epiphyseal. epiphyseal line or epiphyseal plate, and this is where bone grows. This is the site of bone growth. So when this bone is going through its growth phase, which goes, from birth, or actually before birth, your bones are growing up until, maybe your mid-20s, we'll actually see an opening right here. And this is how your bones get longer. This is how they get bigger. They grow right from this location here. Eventually, you get to an age where you're not going to grow anymore. Your body's done. Body knows there's no need to grow anymore. These plates seal. And that's when we say the growth plates are sealed. That person isn't going to grow anymore. Like myself, I'm well past the age of growing, which means my bones have sealed epiphyseal plates, have sealed growth plates. Oopsie. And so this is the epiphyseal plate. And you can see there's an opening right here. This isn't really just open, there's cartilage. And then the cartilage eventually hardens when we get to the point that we don't need to grow anymore. The age of that this happens depends on your genetics, and why it happens. That's a really good question. There's probably some instruction in our DNA that says these bones can't get any bigger. If they do, they'll probably, be structurally weaker. So it just tells the bones, nope, we need to seal this. We need to, basically what happens, this is all type of cartilage, and that cartilage, it just hardens. It turns, instead of that dense connective tissue that it is, that's flexible, it turns into more rigid bone. And then the bone just can't grow anymore. And again, there's probably some reason for that. The body knows the bones can't get too big. If they were to just keep growing, they may get too weak and break. And those instructions are hidden in our DNA, in all of those tens of thousands of genes that we carry from our parents onwards. But this is what it looks like for somebody's bones that are still growing. Now, if you are still growing, which usually growth stops anywhere from like 18 to mid-20s. It just depends on the person. If you were to break your bone, and that break happened to affect this plate in any way, it would be a really serious situation. And so anytime you break a bone, you want to make sure you go to the doctor so they can take an x-ray. And one of the things that doctor is going to be looking at when they're looking at where the break is in your bone is if it's anywhere near this plate. Because if you're still growing, that doctor needs to make sure that they mend that bone just the right way so that that plate can keep growing in the proper direction. Sometimes these breaks occur in a direction that makes it so the bones start to grow incorrectly or abnormally, and if you don't get a bone looked at under an x-ray after it's broken, sometimes that can happen. Sometimes breaks can occur that just destroy this weaker epiphyseal plate, this growth plate, and that bone won't grow anymore if that's the case. So you got to make sure that a doctor takes a look to see how serious those breaks are. But this is the epiphyseal plate in the epiphysis of one bone. This is probably the femur, and then so this is the shin bone, and then one of the bones the thigh bone, and then a shin bone here. And you can see the epiphyseal plate up at the top of another bone here. This is what the plate looks like when it's fused, when a person's done growing. And you can see clearly this is a knee, that's a kneecap, this is the femur, and then these are both of the shin bones. So this is the thigh bone, both of the shin bones. This is the joint here where the two bones attach to each other. And then you can see this plate is hardened. It's sealed. It's not going to grow anymore. So this person would be full grown. And that's one of the ways sometimes they'll look to see if you're full grown. They'll take x-rays of particular bones in your body, and they'll look at these plates. If it looks like this, they know your body's done growing. If it looks like that, they know you still got some more growing to do. Can't really necessarily tell you how much. That's more determined by your genetics, more determined by your parents, their parents, and so on. Okay, the long bone also is made of compact bone. The compact bone is in this diaphysis center shaft here. Oops. Compact bone is much more compact than the spongy bone. Here's spongy bone up here. Compact bone is down here. Inside the compact bone, there's a marrow cavity. And this only occurs in the diaphysis. In the epiphyses, you have spongy bone that creates these little cavities. And red marrow can be found in all of these cavities. Down here, you do have a cavity, but it's filled with a different type of marrow, which we call yellow marrow. Now, yellow marrow, instead of having the job of making blood cells, it does, well, I don't want to go there. Instead of making blood cells, what it does is it stores fat for us. And so if the body needs energy in some type of a long-term starvation situation, the body can actually harvest energy out of your bones. And it harvests energy from the yellow marrow, from the inside of your bones. And if you've ever eaten marrow before, from like a cow or a chicken, you break a bone open, you suck the center out after it's cooked, it's kind of slimy. It's adipose tissue, it's fat. It's where we store fat. And so it's actually a delicacy because it's tasty. Fats tend to be very tasty to us humans. But the reason it's tasty is because of what's stored in there, all that fat that's stored in the adipose tissue. And so we call this yellow marrow. We call the marrow found up here red marrow, which you can't see it in this diagram. You'll see it in the image. Okay, I'm just giving you examples of life things. It's maybe gross though, you're right. Now in the marrow cavity, here's the marrow cavity over here. Here's the compact bone. You can see these little red lines. These are blood vessels that run into the compact bone. There's an inner layer of compact bone that looks a lot more like spongy bone. We call this the outer covering of the marrow cavity. Oh, I'm sorry, I skipped ahead. We're talking about the periosteum, excuse me. So around the compact bone and around the spongy bone, you have this outer covering. And this is where you find all of the blood vessels and the nerves of the bone. Your bone does not feel any pain. Or let me say that again. You don't feel any pain in your bones. You do, however, have nerves in this outer covering of your bone, which we call the periosteum. This outer covering is dense connective tissue, so it's tough. It provides a little bit of protection for that bone, but it also holds all of the blood vessels and the nerves for that bone. And so if you ever had bone pain, what you're actually feeling is pain in the periosteum, because we don't feel pain inside of our bones. Because you actually have nerves that run into your teeth. The teeth are a little bit different. They're more of a specialized type of bone. That's why you would feel it. The outer portion of the teeth is very much similar to compact bone. And we don't have any nerves in that type of material. We'll actually be talking about teeth a little bit in another unit later. So the periosteum, it houses our nerves for the bone. It also houses the blood vessels. Now, why would we need blood vessels in bone? Why would we need to get oxygen, to get nutrients, to take away carbon dioxide in bone? Isn't bone just minerals? Or is it living tissue? Well, Kim's asking to keep it alive. Jason says so the bone won't rot. Okay, good thinking. Liliana says living tissue. Do you remember when we were talking about connective tissue earlier on this year? To keep it strong, Gloria? It's very good. Remember I said bone is a type of connective tissue. Remember I said all connective tissue has living cells and a non-living matrix. So bone is a connective tissue. It has living cells that need oxygen, that need nutrition, that need to be able to create that non-living matrix and sustain it. And so we need to get blood flow into bones because some of them, or parts of that tissue, is living tissue. There's living cells inside of this hard tissue here. This hard matrix, basically, because it's connective tissue. And so we got to have blood vessels coming in there. So the periosteum basically holds the blood vessels so that they can then go into the different parts of the compact bone. You can see the periosteum here getting pulled away from the bone a little bit. It brings the blood vessels into the bone, and then those blood vessels then have smaller capillaries that go into each of those little canals, like you see here. So the periosteum itself contains blood vessels and it contains nerves so that the living parts of the bone can stay living, so that they don't die and rot. And so that the bone can continually make new matrix to keep it strong. Now, inside the marrow cavity, what I was talking about before, there's this layer of spongy bone, or it's like spongy bone, right inside where we have that compact bone. And we call that the endosteum. So we have the periosteum, which literally means outer bone. Perio is outer, steum is having to do with the bone. Endosteum, inner, literally. Endo means inner. Steum means of the bone, or osteum means of the bone. So inner bone, outer bone. This lines that marrow cavity where we find the yellow marrow. I don't know why it has that appearance. So we have the diaphysis, which is the center. We have the epiphyses. One epiphysis here, one epiphysis here. The epiphyses they contain spongy bone, which contains red marrow, which is used for making blood products. You can just say used for making blood. You have the epiphyseal line, which is the site of growth. Then you have compact bone in the diaphysis. Inside that compact bone, you have yellow marrow in that marrow cavity. The lining of the marrow cavity is the endosteum. And then the very outer layer of that bone is known as the periosteum. And that's what brings in the blood vessels, what brings in the nerves for that bone. So here's what bone looks like with that red marrow inside of it. This is a pretty accurate diagram. Here's the proximal epiphysis. Don't worry about the metaphysis. We're not going to worry about that in this class. That's just the area of growth, basically. There's the epiphyseal line. You can see it looks a little bit different from our diagram. On the very end is the articular cartilage. This is where the bone has its joint with another bone, and that articular cartilage helps reduce friction. Here is the marrow cavity inside the diaphysis. This would be filled with yellow marrow. It looks like they just emptied it out here. after it looks like they cut it open. Of course, it's just a diagram. The periosteum has the nerves and the blood vessels. It's on the very outer part of that bone. And then here's an actual femur. So it's partially sectioned, so it's partially cut. And you can see the compact bone versus the spongy bone. Here's a spongy bone without red marrow. The red marrow and the yellow marrow dries up. It's fatty. So once you cut these things open, give it enough time, the red marrow disappears. The yellow marrow disappears. You can see, you can't quite see the epiphyseal plate. I think here's one here. There's probably another one right here. They just didn't cut it deep enough to be able to see it. And then you can see the endosteum. This is where you would find the yellow marrow. And so we're going to be doing an activity where you get a chance to look at some images of a long bone, and you're going to identify them. We'll probably be doing that on Friday.